This is the video that answers the 6 questions that were on our last vidQ in Algebra 2 about these 6 problems that were to solve by factoring. The first one, 3k squared plus 72 equals 33k. Step number 1 is get it into standard form, meaning make it equal to 0. Next, simplify as much as possible. Always factor out and divide out any common factors of all the terms. Now I've got k squared minus 11k plus 24. So I'm asking now, what would you multiply to get 24 but to add to get negative 11? And the answer would be negative 8 and negative 3. So I've got k minus 8 times k minus 3. The solutions being k would equal 8 or k would equal 3. For problem number 2, once again, step number 1 is get it into standard form, have it equal 0. And I've already got just a 1n squared, so that's nice. So once again, I'm looking at this and saying, what do I multiply to get 18, but add to get positive 9? And the answer would be 6 and 3, so n plus 6, n plus 3. The answer to solving this would be n equals negative 6 or n equals negative 3, because that would make the statement true. Problem number 3, step 1, get it into standard form, so it's equaling 0, but I still have to collect like terms, so I've got these v terms to collect, I've got these v squared terms to collect, and I end up with v squared minus 7v plus 12 equals 0. What do you multiply to get 12, but add to get negative 7? The answer would be negative 3 and negative 4, so it factors to v minus 3 times v minus 4. The solution to this equation after we've factored it is that v would equal 3 or v would equal 4. In problem number 4, step number 1 is to get it equal to 0, standard form, and then we've collected like terms, and well, this is a little bit harder. Now I have to think about factoring, and I'm not quite sure. This is a perfect square here. That could be, 3n quantity squared. This is a perfect, well, it's not a perfect square because it's negative, so that doesn't work. So because of that, I have to start thinking about my other factoring rules, and one is to multiply this a, 9, times the c, negative 16, write that product. I get negative 144. Now I make a table of all the pairs of factors. I'm looking at factor pairs, just two numbers that would multiply to make 144, 1 and 144, 2 and 72, etc. You can see this whole list here. Once you've made your list of factor pairs, you're now going back to this middle term here, the 6n. I'm just looking at the positive 6, and I'm looking at the factor pairs whose difference is 6. And why do I say difference? Because this subtraction symbol right here is saying that the factor pairs, you're going to look at the difference between them, subtract them, and get 6. And you look down this list, and I'm looking at, well, I don't seem to see, nope. None of them subtract to get 6, and those are the only factor pairs for 144. So that means it's not factorable. If it's not factorable, what would I do? Well, in this problem, it was just to solve by factoring. The answer is it's not factorable. But what would be the solution to this quadratic? Well, we'd have to use the quadratic formula. And recall that I've said in class, you need to write down what is my A, what is my B, and what is my C, because there's been too many errors in class regarding what numbers I plug into the quadratic formula. So please take this few seconds, it only takes a few seconds to write these things down. You should also have written the quadratic formula with the A, the B, and the C. Here I just wrote it in and plugged in everything. And notice that if I have a negative 16 here and I've got a negative 4, and all of this is multiplication, this is going to be positive. So I'm going to multiply negative 4 times 9 times negative 16 and see what happens. Well, I end up right here. I got 576 and it's positive. Adding that all together, I get 612. And I've broken it up into two fractions just to simplify a little bit easier. And I notice that that square root of 612 is 6 root 17. And then I'm going to simplify because 18 and 6 are both divisible, and so I end up with 1. That should be negative 1. I'm sorry, I see right now that I have a negative here. So I need to make this also a negative. So there we go. Now we've got a negative 1 plus or minus the square root of 17 all over 3. And that would be the final solution to this problem. The fifth problem we've got is, we've got this one right here. Whoops, let me just, there we go. We've got, and the first step is to make it into the standard form, equal to 0. Simplify as much as possible. All those numbers are divisible by 5. And now I have 2r squared minus 13r minus 7 equals 0. Now, I just did the factorization of this because the reason I didn't do the factor tip thing and make the product and all that is because I noticed that 2 is a prime number. So I know that I'm going to have, since I have 2r squared here, I'm going to have 2r and 1r. There's no other possibility for that. And similarly, this 7 is a prime number. So I know that in these two places, it's going to be 1 and 7. And I just look to see which one of these are going to give me these products, 1 times r and 2 times negative 7. When added together will give me negative 13. You could do the factor tips that I showed, but I got that. So now the answer to this one is r equals negative 1/2 or r equals positive 7. In problem number 6, I get it equal to 0. I try to figure out, is there anything I can reduce it by? There isn't. So this time I'm going to do the little factor tip where I take the a, the 3, and the negative 16, multiply them together, and I get 48. This really should say, and I should put it here, this should say negative, whoops, sorry about that. This should say negative 48 as we go on there. So we're looking at these pairs, factor pairs of negative 48. And so there's all the factor pairs of negative 48. And now what I want to know is, of those factor pairs, which one of them would have a difference of negative 8? And I look for them, say what's the one's going to have a difference of 8? Well, 4 and 12. And I want it to be negative 8, so I know it's going to be negative 12 and positive 4. So now I write it over here. And you'll notice that I wrote this right here is the 4x plus, actually minus 12x. That is the same thing as negative 8x. I now group it into two different groups, and I'm going to factor each of those groups. In the first group, x comes out. In the second group, negative 4 comes out. In both of these sections here, I've got a group of 3x plus 4, and I have a group of 3x plus 4. So I factor that out, and what I'm left with is the x minus 4, so I put parentheses around that. And now, as you can see, I have completely factored the polynomial. I've got two groups being multiplied that equal 0. So the solutions for this are negative 4/3 and positive 4. And that's the solution, and that's the last of the 6 problems that were on the VidQ.